Next stop for man, the planet Mars. On this red planet, there exists no recognized life due to its thin atmospheric layer and harsh climate. With little to no protection from the sun, the surface of Mars remains dry and barren. This may leave the impression that life is impossible on Mars, but there is one factor we have yet to consider. Hi, my name is Allyson Jamka. I'm a chemistry major at Orange Coast College, and I'm one of the primary participants of this project. Before we send humans to Mars, we have rovers up there, which are exploring everything that's on the planet. The Perseverance rover, along with other rovers we sent up there in the past, are exploring the environmental factors of the planet. There are actually over 1,000 cave entrances on the planet, so our plan for this project was to send our rovers down into the caves and see what the conditions are like and if they could foster life. So the brainstorming process took up probably the majority of the project. We went from different kind of rover designs, the first one being a replica of the Perseverance rover, and then next we went to a rocker bogie system, and finally we decided on our TriStar wheel design, which is what we built our project after.
Hello, I'm Sajjad Sharif. I'm a student at Orange Coast College, and I am the key designer for this project, the TriStar. The inspiration came from watching YouTube videos during the research phase, and after team vote, we decided to go with this specific TriStar model. I have 3 years of 3D printing since high school, and after that I didn't really have to get to utilize it until recently, which I designed the gears and learned many new things about gears and know what gears were, such as the meshing between two gears, there's the backlash between two gears. I basically had to learn that from scratch in order to make the gears. The first issue I encountered was dimensions. I didn't really have a specific dimensions to go off of, and then I really had to learn to use a caliper more precisely than ever before. I did use a caliper before, but this round I learned to measure it more precisely, and this precision helped me to press fit those items that was printed later on together. As for the SolidWorks software, I learned to use gear assembly, dynamic motion, and how to utilize the gear toolbox built in the SolidWorks itself.
So I've actually never used a 3D printer before until this project. So luckily I had an associate lend me a couple of his printers, and he taught me how to use them. I learned how to splice files, and I learned how to, set up the printer, troubleshoot the printer. There were a couple issues we stumbled upon. For example, one of the printers was pretty bad with its leveling, so we got a device to help with that.
Hi, my name is Sarah Gray, and I'm majoring in environmental engineering. Getting the parts, I mostly went to Micro Center, Home Depot. Micro Center was pretty far from my house, so it was quite a bit of a drive, but I managed it. Home Depot's super close, and then a lot of it was from Amazon, so that's where I got most of my parts. For availability, we wanted to use the Raspberry Pi originally, but we ended up going with the Arduino Uno instead. We also wanted to use servo motors, however we realized that the voltage was too low, so we ended up getting DC motors instead with 12 volts. We also needed to go to Micro Center and buy female to male wires, because originally we just had male to male wires as well. Yeah, so the resources I used Project Hub, a lot of YouTube video, especially to get that initial design, and then Dr. Bender, of course, helped us with a lot of this project. The frame of our project includes the lightweight plastic, the breadboard, and the Arduinos. Attached to the Arduino is the motor driver, environmental shield, LED lights, camera, Bluetooth module, sonar sensor, and solar panel. All of this is connected with jumper wire. The 3-spoke wheels are comprised of 3D printed gears, 12 wheels, and 4 DC motors connected with copper wires and solder.
Hello, my name is Reagan Arvidson. I'm an upcoming sophomore at the University of Southern California, hoping to transfer into their astronautical engineering program. Coding was very new to me. My first coding experience was taking an Introduction to Java class in the spring. So I was very limited with what I could do with Java alone, which made it even more difficult when coding all the sensors and everything else because they were in a different coding language, which was C++. So there were a lot of terms I was unfamiliar with. I had to try and learn. And also, when I did find code online, I had to figure out what part of the code to change to make the sensors or any data coming in do what I want it to do. So the environmental shield senses a lot of things. It senses temperature, pressure, humidity, UVA, UVB, illuminance, and UV index. So a lot of those could be very helpful for Mars and caves specifically. For example, if the rover does go outside, it can get the UV index, it can take in that radiation, and also compare it to when it goes into a cave. If anything's peeking through, the more radiation's getting in there, the more potential there will be for some life. So caves are super important to Mars because they're much more likely to provide shelter for life and for humans if they ever went there. Mars is very dry. It has a very thin atmosphere compared to Earth, and that's caused for a lot of radiation and other harmful substances coming from the sun and other places to disrupt any processes going on the surface. So in the cave, you're more sheltered, there's less radiation, you're much more likely to find something untampered with. So if humans, or when I should say humans, colonize Mars and go up there and explore, I feel like caves would be a great place to just sit tight while we're building all our infrastructure, making sure there's safe living conditions, and we can find the spots that are most suitable for life, or our life and the life of anything else that's there.